This is the last video for 5.1 and I'm going to use it to go through the answers to the exam questions. The first question you're asked to state in words the 3D shape of an s orbital and p orbital. So s orbital you're going to write spherical, p orbital you're going to write dumbbell. If you look back at the mark scheme, the common mistake here was to write circular, okay? You're asked the 3D shape. A circle is not a 3D shape, it has to be spherical. With the p orbital, there are more acceptable answers. So if you didn't write dumbbell, if you wrote figure of 8, they accepted peanut, they accepted hourglass, okay? But you're asked to state in words, so drawing a picture is not going to get you a mark. The next one, according to the mark scheme, this is quite badly answered. You're asked to describe the relative energies. So relative just means that you're comparing them to each other. So you're looking at the 2s and you're looking at the three 2p orbitals, okay? 2p orbitals are higher in energy than a 2s orbital. That's all you need to say, okay? Or you could say 2s is lower in energy than the 2p. You could have drawn yourself a diagram either, and that would have gotten you marks on the mark scheme. That gets you your first mark, comparing 2p to 2s. Then they want you to talk about the three 2p's in relation to each other. You're going to say that the three 2p orbitals are all equal in energy, and that's going to get you your second mark. On the mark scheme, it said that people or students wasted time talking about the number of electrons. Okay, that's not what's asked for here. You're just talking about energy. The next one, and according to the mark scheme, this was really badly answered, okay? So it's really important that you know how to answer these questions. State the number of electrons in the fourth shell, okay? So if it's the fourth shell, then I know it's n equals 4. And that means that there are going to be 4 different subshells. You're going to have S, you're going to have P, you're going to have D, and you're going to have F. Every time you've got S, you've only got 1 orbital. P, you've always got 3 p orbitals. D, you've always got 5 Ds. And F, you've got 7 Fs. And we never have to fill the F orbitals, but you're still supposed to know that there are 7 of them. Okay, if you count up all of the orbitals you've got 1 and 3 is 4 and 5 is 9 and 7. You've got 16 orbitals. You know that each orbital can hold 2 electrons. Therefore, in total, you've got 32 electrons in the fourth shell. You can just learn that number off by heart. 32 electrons in the fourth shell. Make sure you know it. How many orbitals are there in the third shell? If it's third shell, then n equals 3. If n equals 3, then I must have 3 subshells. I'm going to have S, P, and D. Okay, S, as we said, there was 1. P, there is 3. D, there is 5. 1 and 3 is 4. 4 and 5 is 9. You've got 9 orbitals altogether. Again, that was apparently very poorly answered. Okay, in question 3, this should be straightforward. You're told the atomic number is 63. The atomic number tells you the number of protons, okay? When you want to find the number of neutrons, they're telling you you're looking at 153 as your mass number. So it's mass number 153 minus atomic number of 63, and that gives you 90 for neutrons. For the electrons, if this was an atom, okay, you would have 63 electrons, but it's an ion. They've told you you've lost 3 electrons, so you did have 63, then you lost 3, you are left with 60 electrons. In 3b, okay, a similar style question to what we had above, number of electrons in the 1s subshell, okay, if it's 1s, there's only 1 orbital there, number of electrons, the number of electrons, is going to be 2. The number of electrons is going to be 2. In a 3p orbital, they're asking about one specific orbital, so the answer is going to be 2. In the third shell, okay, we counted above that we had 9 orbitals in the third shell. Each of them can hold 2 electrons. That gives you a total of 18. How many orbitals are occupied in a silicon atom? Okay, so the easiest thing to do is to write this out. Silicon's got 14 electrons. Write out the electron configuration, count how many orbitals. Okay, however, really easy to fall into this trap. If you use the p shortcut and just lump all of the p orbitals together, you'll write it out as follows, and it's very easy to then go 1, 2, 3, 4, 5 orbitals. Okay, you have to remember that within that 2p6, you've got 3 different p orbitals. You've got a 2px, a 2py, and a 2pz. Okay, when I get to here to my 3p orbitals, remember they fill singly before they fill in pairs. So you're going to get 1 electron in the px and 1 electron in the py. They don't both go into the px. They fill singly before pairs. So when you write out the electron configuration in full, separating out your p orbitals, you'll see you've got 1, 2, 3, 4, 5, 6, 7, 8 electrons. 8 orbitals that are full, so your answer is going to be C. The next one asks you to write the electron configuration of manganese, okay? It's starting you off at 1s2, which tells you that you are not going to be using that noble gas shortcut. You have to write the whole thing out in full, okay? When I'm looking at manganese, I see that it's down here in period 1, 2, 3, 4, okay? So that tells me that the first, second, and third shells are going to be totally full. So when I'm writing this out, without even thinking, 1s2, I'm going to write 2s2, I'm going to write 2p6, I'm going to write 3s2, I'm going to write 3p6. Okay, I'm going to write all that because I know straight away that all of those are going to be full. And then when I come down here, I can see that I've got 1, 2, 3, 4, 5, 6, 7 electrons left to assign. I know that the 4s will take 2 and the 3d will take 5. When I'm writing this, I'm going to put the 3d first and the 4s second, but you will get a mark if you've written that the other way around. Quick check to make sure I'm right. Manganese is 25 electrons. These numbers should add to 25. 2 and 2 is 4, and 6 is 10, and 2 is 12, and 6 is 18, and 5 is 23, and 2 is 25. Oh, sorry, I've written that in the wrong place. This is supposed to be written up here. 2s2, 2p6, 3s2, 3p6, 3d5, 4s2. This one here is supposed to be bromine. Okay, so I'm doing bromine down here. When I'm looking at bromine, I see it's all the way over here, okay? And it's a p block element. So I know that the first 3 energy levels are going to be full. And in that 4th energy level, I know that the 4s is going to be full. The 3d is all going to be totally full. And then I'm picking up here at 4p. So I am going to write a full 3d orbital, 3d10. Then I'm going to do my 4s2, and now I'm in 4p, okay, and it's in group 7, so I know it should have 7 electrons in its outer shell, which makes that a 5. I'm going to double check that I've done that right. I've got 35 electrons. 2 is 4, 6 is 10, and 2 is 12, and 6 is 18, and 10 is 28, and 2 is 30, and 5 is 35. Please do that little check at the end. It's really easy to make a mistake with those. It's an Mg2 plus ion. Magnesium normally has 12 electrons. If you lose 2, it will only have 10 electrons left. Therefore, your answer is going to be B. You can also see that B has a full second shell. When magnesium loses 2 electrons, it has the same electron configuration as neon, which is why you've got a full second shell. So for this question, you could write it all out, but if you look at your periodic table, there is a quicker way, okay? So they're asking you the greatest number of singly occupied orbitals. So you want an orbital that has got 1 electron in it, but doesn't have 2, okay? If I look at carbon, carbon's here in group 4. I know it's a p block element, and it's got 2 electrons in p orbitals. Therefore, it's going to have a px and a py. So it's got 2 orbitals that only have 1 electron in them. If I look at chlorine, it's also a p block element, but it's got 5 electrons, 1, 2, 3, 4, 5 electrons in p orbitals. It's going to have 2 of them in the px, 2 of them in the py, and 1 in the pz. So it's only got 1 orbital singly occupied. So carbon had 2, chlorine has 1. Calcium is over here. Calcium has got everything full, and then it's got its 4s as its outer, and its outer is also full. So calcium's got no singly occupied. And then gallium is here in group 3. It's again a p block. It's got 1 p electron, which is going to be in the px, which gives it 1 singly occupied orbital. So carbon has got 2. Carbon is going to be your right answer. I mean, you can draw them all out if you want to, but you can just look at your periodic table. I mean, group 5s are going to have the most singly occupied because they've got 1, 2, 3 p electrons. It'll go px, py, pz, giving them 3 singly occupied 3 p orbitals. Next one is electron box. You're asked to label the subshells. You've got 1s, you've got 2s, you've got 2p. You're doing this for nitrogen. Nitrogen has 7 electrons. You need to show that you're using opposite spins, and you need to start with the lowest energy and fill singly before you're filling in pairs. So I'm starting with 1s. I'm putting 1 electron in there, and then I'm going to put my second electron in there also. Then I move to the higher energy level, which is 2s, and I fill once, and then I fill it again. Then I move on to the 2p. The 2p's are all equal in energy. Because they're equal, I fill them singly before filling them in pairs, and there are my 7 electrons already assigned, okay? If the orbitals are equal in energy, you fill singly before you fill in pairs. Back here, the 1s was lower in energy than the 2s, so I fill that completely. Then I moved on to 2s. It's lower in energy than 2p, so I fill 2s completely. Then I move on to 2p. Because they're the same in energy, I can fill singly before filling in pairs. Next one, similar question, except you've got oxygen. Oxygen has got 8 electrons. The first 2 are filled in for you. Again, I'm going to fill the 2s completely. And then I'm going to move on to my 2p. I've got 4 electrons left to assign. I'm going to go 1, 2, 3, 4. Okay, there's my 8 electrons assigned. I filled singly before I fill in pairs, and I've got electrons with opposite spin together. Question 10, you're asked to write out the electron configuration. Okay, you're not going to be using any shortcuts. Again, I can see iron is down here, so I know those first 3 shells are going to be totally full. So I'm just going to straight away write 1s2, 2s2, 2p6, 3s2, 3p6. Okay, and then I'm getting down here and I can see iron has 1, 2, 3, 4, 5, 6, 7, 8. Another 8 electrons for me to account. But of those 8 electrons, it's lost 2, meaning it only has another 6 electrons. I know the 2 it's lost have both come from the 4s, so the 6 it still has are going to be in 3d. How many orbitals can paired and unpaired? I'm just going to be looking at all of these orbitals are full, so they're all paired up. I'm going to look at the outer one, which is 3d. I know D, there's 5 different orbitals. I've got 6 electrons in there. 1, 2, 3, 4, 5, 6 electrons in there. Remember, they fill singly first, which means I'm going to have 1, 2, 3, 4 orbitals with unpaired electrons. The next one, you're asked for zinc. Okay, zinc is all the way down here, so I can see it's right at the end of the transition elements, just before you've moved into the p orbitals. So I know that 3d orbital is going to be totally full. So it's going to be 1s2. All of these ones are going to be full. The 3s is full. The 3p is full. And then I know that the 3d is now full. And then you've got 4s, but it's got no p electrons. This should be straightforward, okay? The important thing here is that you're not rounding. Use the full mass that they've given you. You multiply the mass by the percentage, then you add that to the mass multiplied by the percentage. You divide it all by 100. You get this as your answer. You're asked for it to 3 decimal places. So to round this to 3 decimal places, it's 79.904. That 5 will turn into the 3 to a 4. Already done the electron configuration of bromine, so I won't do it again. This last one, okay? Electron configuration of element X. I don't need to know what element X is. I just need to know what group it's going to be in. So in the outer shell, I've got 2 s electrons and 4 p electrons. That tells me it's got 6 electrons in the outer shell. That tells me it's in group 6. And if it's in group 6 and it's forming an ion, I know that that ion is going to have a -2 charge. So if my non-metal has a -2 charge, I know sodium has a +1 charge. How many sodiums do I need to balance out the -2 charge? I need 2 sodiums to balance out the -2 charge. So my formula is going to be CNA2X. That is the question.